Lesson 5.3, Interpreting Rate of Change and Slope. So we've talked about rate of change before, and here we have a definition of rate of change in change in y over change in x. Notations we've used have been that to represent change in y over change in x. We've also talked about rise over run when you're looking at it graphically. And we've also talked about how you could actually use the formula y2 minus y1 over x2 minus x1. Again, not my preferred method, but different ways to represent slope or rate of change. So in this example, we're looking for the rate of change based on what's happening. So here we always look at both, the y and the x. So you got to pay attention here. Right here we had a change in 1. But here in the x we had a change of 2. Now that's important because here we had no change. And then here we had a change of 2. Then here we had a change of 2. Here we had a change of 3. Here we had a change of 5. And then here we had a change of 4. So there's no consistent set pattern. So this is not a constant rate of change. This would not be a linear function here. But if we want to, we can determine rates of change based on certain criteria. So in this particular case, it's asking us to find the rate of change from 2003 to 2004. Now, this is measured off a year, 2000. So year 2000 would be like year 0. So if we were doing our table, you could correspond year 2000 to our 0 term in our table. And then term 1 would be year 2001. And then term 2 would be year 2002. So they don't show the years up here. They show what it is after 2000. So 2003 would be term number 3 because it's 3 years after 2000. So what do we do here? We take the y value for 2004, which was 37, and the y value for 2003, which is 37, and we get 0. So it increased 0 cents, which we could see from the table there. You don't necessarily have to put it into a formula. What about from 2004 to 2006? When 2006 it was 39. In 2004, it was 37. So what do we get? We get 2 over 2, which is 1. So you got to be careful. It changed 2 cents, but it was over a 2-year period here. So determining rate of change can be done multiple ways. Now, what the book is doing down here is basically using what we refer to up here as the formula. And again, I'm not too partial to the formula. I just like to look at it in a table and determine what changed or how did it change. So then it says take the points and plot them and look at the postage cost and connect the points with line segments. Okay, so when you connect with line segments, you're going to see that it's not a consistent line. You're going to see individual. So if we go back and plot the points individually, you're going to see that they're not consistently linear. You have segments that are lines, but they're not all connected. So let's go to the next one. So in the next one, we're describing it as rise over run. Why? Because we're looking at it graphically. So what did we rise here? We went up 3. From 1 to 4 is 3. What did we run? We ran across 1 from 2 to 3. So 4 to 1 was an increase of 3. 3 to 2 was an increase of 1, and then we get 3 over 1. It's a positive slope because it's going up. Now again, they're using the formula. I don't really like this. So if I'm looking at it, here's what I do. Rise over run. So here is my change in y. I went from 3 to 0. So what did I do? I went down 3. my run, my x, I went from -2 to 1. So what did I do? I went to the right, which is a positive. How far did I go? I went +3. 3 times to get from -2 to 1. So when I do that and simplify it, what do I get? A -1. Well, that makes sense. Why? Because my line is going down, so I should have a negative slope. So here it asks you to find the slope of each line. So what I would like for you to do is go ahead and take a second, try to find the slope of each, and then we'll check them. So here's what you should have ended up with. In this particular one, change in y, you went from a -3 up to 3, so you went up 6. You went from 0 to 5, so you went up 5. So that's +6 over +5 since we went up and then we went to the right. So you get 6/5. In this one, and I always go my points from left to right. So in this case, I'm here left to right. So what did I do with my y's? I went from 2 down to -3. That means I had to go down 5. I went from -3 to a -2, which means I moved to the right 1. So that's positive. -5 over 1 is -5. Now, in this case, I would probably leave it as a fraction, though, just because if I'm having to use it on a graph, I, again, want to use rise over run. So as we continue on, here it is using the slope formula and plugging in. Again, I'm not too partial to that. However, it does work if you want to do slope. Now, here we have an example of one where if you look at our points, they all have the same x value. So how is that possible? How can they all have the same x value? Well, if you graph that on a line or on a graph equation, so I'm going to graph the point 3, 2, which would be here. Graph the point 3, 4, which would be right here. 3, 6, which would be up here. And then 3, 8 is going to be up here. I get a vertical line. Now this is important. Remember we talked about what is a function. Well, vertical line, if it doesn't pass the vertical line test, which this one doesn't because it is a vertical line, that is not a function. Now that's important because if it's not a function, that means it has no slope, or in this case, they're calling it undefined. Okay, now what about an example of a line that goes horizontally? So let's say I have my points here, 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 and here, and then I draw my line through, and I graph it, and it's horizontal. Well, then it does pass the vertical line test. So due to my arrow here, it's going to pass the vertical line test. This is a function, but it's not going up or down. So what does that mean for this line? That means it has a slope that is 0. It's not going up or down. It's just flat. So we can always look at lines and determine positive, negative, 0 slope, but we also have this one that's called undefined or no slope, and that's when you have a vertical line. So here it asks you to find the slope of each line passing through the given point. So first we have one using the graph, and then we have one using a table. So what I would like for you to do is take a minute here to try to do this, and then we'll check them. So in this one, I did the graph, and I looked. My y went down 14, my x went up 3, so I get -14 over 3. And again, you could use the formula, you could use a table, you could do whatever you want to. Here they give us a table. So rather than do the formula, I did change in y over change in x. What did my y do? It went up 0. What did my x do? It went up 1. So I get 0 over 1, which is 0. Now here is an important aspect of this. You can use the calculator. If you type 0 divided by 1 on the calculator, you get 0. However, let's say it were a vertical line where my x's were all the same. Well, in that case, my change in x is 0, but my change in y would have been, let's say, +2. So then I get, or change in x would be 0 and change in y would be +2. So if you do your formula, change in y over change in x, you get 2 over 0. Well, if you try to do that on the calculator, it's going to tell you error. Why is it going to do that? Because that's the case where your slope is undefined, because it's a vertical line. It's not a function. So your calculator will tell you when it is 0 and when it is undefined based on what you type into the calculator. But again, you have to recognize what to be able to put in. So then it's asking us here to interpret slope. What does slope mean for a given situation? Well, we have an example A here to the side, and they talk to you about your heart rate and all that. So what we're going to do is we're going to skip to the your turn problem here, and we're going to do that. So right here, it says the graph shows the relationship between the temperature expressed in Fahrenheit and the temperature expressed in Celsius. So there's a relationship here between converting them. So in this case, again, I'm going to look, what did my y's do? My y went up 15. What did my x do? My x went up 27. So I get change in y, which is 15, over change in x, which is 27. You need to always simplify fractions. I know 3 will go into both of those, and I get 5/9. So my slope is 5/9. What does that mean? That means for every, remember it's change in y over change in x, every 5 degrees Celsius increase means an increase of 9 degrees Fahrenheit. So every time the temperature goes up 5 degrees Celsius, that means it's really going up 9 degrees in Fahrenheit temperature. That's what it means by interpret the slope. So I'm going to give you a minute to try to answer number 12, and then we'll check it. All right, so in this next example, I did my change in y. My y went up 1,000. Change in x went up 20. Change in y over change in x, 1,000 over 20 is 50. Now, what did the y represent? It said the number of cubic feet of water, feet cubed. X is hours. So what does this mean? That means it's a rate of change. That means the reservoir is flowing, or water's going into the reservoir 50 cubic feet per hour. So after 2 hours, it would have gone in 100 cubic feet. After 3 hours, 150 cubic feet. So the slope gives us a rate as to what is increasing and or decreasing. So for lesson 5.3 on page number 227, you are going to be doing numbers 1 through 12 and then 13 through 25 odd. 1 through 12 and then 13 through 25 odd.